This is another theoretical video on the roadmap towards the most flexible and scalable blockchain tech. Rejoinable forks, contract-level subchains, contract-level shards. To get to this point, we have implemented and presented a WebAssembly modular blockchain compatible with any Cosmos SDK blockchain, where the blockchain itself is made up by replaceable and upgradable WasmX modules that work on different types of storage, public or private, in consensus or consensusless. This is flexible enough to upgrade the chain while running, upgrade at any level, consensus, governance, bank, staking process, etc. So now we have this flexible base. We can create special contracts. And these contracts can be abstract subchains where they store the transactions and/or blocks of a subchain directly using the main chain's infrastructure. Or these contracts can be fork portals to an actual subchain that has its own consensus protocol. The assumptions or system requirements are that the state is mergeable, that contracts can become independent chains with their own consensus protocols, that contract chains can have an alpha state and an omega state, that contract chains are uniquely contained, and this means that they are contained in one parent chain, the chain that created their genesis or alpha state, and that there is a validator queue where subchains can acquire validators or miners from for running their own consensus protocol. That an adjudicator contract exists, a contract that adjudicates what state can be merged in what order and conditions. And in future videos, we will give more details and demonstrate an implementation of this system. But for today, we will just present the concepts. The alpha state. This is the initial start state of a chain. It is under consensus rules and deterministic. For classical blockchains, we call this genesis state. For chains that can be forked and joined, we call this alpha state. The alpha state is created by the parent chain for a forked or sharded or dependent chain or subchain. The omega state is the final state of a chain. It is also under consensus rules and deterministic. For classical blockchains, this is the death of the blockchain. For chains that can be forked and joined, we call this omega state, and this omega state is merged with the parent chain. A requirement for alpha and omega states is block finality. Now, what is a rejoinable fork? We are not necessarily talking here about merging the entire state of a subchain into the parent chain. It may be sufficient to merge only one or two contracts back to the parent chain, and this depends on the rules set in the subchain's alpha state, created by unanimity of the future validators set of the subchain. When rejoining the parent chain, the omega state is subjected to adjudication from an adjudicator contract, and this resolves any state conflicts that may arise. And based on the level of state intersection, you can be in different cases. When the state intersection is total, we are talking about a full fork or chain upgrade. There is no state to merge. We are talking about competing states of a blockchain. But we can have partial state intersection with a chain and a subchain. And we can have state intersection on select contracts, like roll-up contracts, fork portals for dependent chains that can be rejoined with the parent chain. And in the same category, we can also have mobile individual chains like we demonstrated with our Ganas wallet. In these cases, adjudication is necessary. We can also have no state intersection. And here we are talking about sharded data. The shards are independent from the parent chain and they are rejoinable without needing adjudication. And you can have multiple independent shards. So we introduced the concept of an abstract global chain where all independent chains are shards. The theoretical blocks are the largest unit of time that accommodate one transaction or block of the component chains at the moment of omega state. And time itself can be considered as a beacon chain. And of course, this system can be single level or multi-level, can be bridged or not bridged, and the outcome is elastic scalability, subchains with arbitrary number of levels, and you will also have validation markets and recursive forks and joins. The target purpose for all of this is to attain the ability to process national elections, millions of transactions per hour. And this is the roadmap for our present and future work.